All right, class, we just turned the page. So we're in section 4.3, and we're looking at still laws of exponents. So we're looking at what happens when we have an exponent that's a zero, or what happens when we have an exponent that is negative. So we're on page 192, and we're just going to do a couple of practice problems so that we're really familiar with all the different rules that we've done so far, including power, product, quotient, and now zero and negative exponents. So really we have 5 rules that we're practicing, and that's what we want you to become familiar with, proficient with, as we're working through the remainder of our exponential function unit here. Okay, so let's take a look at this. So anytime it says that if you see a negative exponent, then rewrite it so that it has no negative exponents, but then it says and vice versa. So I guess that means that if there is a negative exponent, that we want to write it as a positive, but if there's only a positive, then maybe we write it as a negative. There's only one example, so let's take a look here. Okay, k to the negative fifth. Now, previous page, we just said that a negative exponent means that it's a flip, it's a reciprocal. So that no matter where that negative exponent expression is, that if it's in the top in the numerator, we're going to put it in the bottom in the denominator, and vice versa. So k to the negative fifth. Now remember, this is k to the negative fifth is the same as k to the negative fifth over 1. So let's go ahead and write the reciprocal 1 over k to the fifth. That's by definition what we're looking at if we're talking about negative exponents. This one right here, m to the 0. 1. Anything to the 0 power, it doesn't matter what it is. If we put it to the 0 power, that it's 1, and we just show that by that expanded notation, that numerator, denominator, everything becomes a 1, and so no matter what the expression is, if it's to the 0 power, then it becomes a 1. I'm going to skip this one right here because I just want you to use the product rule on that and what you know about exponents. This is what I was talking about right here. 1 over p squared. Okay, I want you to pause the video for a second and take a shot at this one right here. Okay, so the idea is that if we didn't have a negative exponent, can we write this as a negative exponent? And I think what they're looking for here is that this is p to the negative 2, and then you could put it over 1, but I'm not going to do that. Okay, this is following the letter Q right here, which I'm guessing maybe yours isn't Q, it's probably E. I'm just going to let you do the quotient rule right there. Let's take a look at this one right here. So this is I see parentheses, so when I see parentheses, I'm thinking power rule, so I know there's a multiplication. But let's just start order of operations. Let's do what's inside of this, the parentheses here. X to the negative 2 over 1. If I see a negative exponent, I'm going to flip it. I'm going to get the reciprocal. So this is going to be 1 over x squared. Now, it's still to that third power. And if I apply my power rule, it is going to, we're going to do multiplication for any exponents that we see inside of the parentheses here. And if there was a coefficient, such as a 2 right here, we would apply that to that as well. And so I'm going to rewrite this as 1 over x, 3 times 2 would be x to the 6th. Now, I suppose I don't need those parentheses there anymore because I've already applied it, but that's what we get there, 1 over x to the 6th. And last but not least, let's take a look at this one. Again, the power rule. However, this one right here with the negative 1, let's just look at a squared times b and put it over 1. So just remember, any expression we have, we can always put it over 1. If I see a negative exponent, that's an automatic reciprocal. Because it's just 1, I'm not changing any of my exponents, and I'm just going to rewrite this expression as 1 over a squared times